before it melts in your mouth, before you taste the sweetness, before you even unwrap it. Chocolate has already traveled the world. It begins in the heat of the tropics. Under thick green canopies near the equator, cacao pods grow in silence. Their pods hang heavy in the humid air. Inside each pod are dozens of seeds, raw, bitter, powerful. These seeds will become chocolate, but not yet. They must be harvested by hand, fermented for days, dried under open skies, shipped across oceans, from small farms in West Africa to processing facilities thousands of miles away. There, heat transforms them. Roasting unlocks hidden flavors. Grinding releases cocoa butter. Precision temperature control shapes crystal structures invisible to the eye. All of this for one extraordinary moment. The moment chocolate meets your tongue. And in that moment, something remarkable happens. It melts. Not by accident, not randomly, but at a temperature engineered by nature and perfected by science. Chocolate melts just below your body temperature, which means the instant it touches you, chemistry begins. Heat transfers. Crystals break apart. A solid becomes liquid. Flavor spreads. Aroma rises. Neural signals fire in your brain. What feels simple is anything but, because inside that smooth melting sensation is physics, chemistry, biology, and a global journey measured in thousands of miles. Today, we uncover the science behind one of the world's most loved foods. This is not just about chocolate. This is about how food works. Welcome to Tiny Food Scientists, where food meets science.
The science of chocolate. Why it melts in your mouth. Have you ever noticed how chocolate melts perfectly in your mouth, but stays solid on the store shelf? That's not an accident, that's science. Chocolate is carefully designed by nature and perfected by humans to melt at just the right temperature. And that temperature is very close to your body temperature. Most chocolate melts at around 30 to 32 degrees Celsius. The human body temperature is about 37 degrees Celsius. That small difference is the reason chocolate feels smooth and creamy the moment it touches your tongue. But to understand why this happens, we need to go back to the beginning. Chocolate starts with cacao beans. Inside these beans is a natural fat called cocoa butter. Cocoa butter is the key ingredient responsible for chocolate's melting behavior. Cocoa butter is special because it can form different types of crystal structures. Scientists call these polymorphs. Some crystal forms are unstable and melt too quickly. Others are too stable and don't melt smoothly. The perfect chocolate you enjoy has a very specific crystal structure, one that melts just below body temperature. That's why chocolate doesn't usually melt at room temperature. Most rooms are between 20 and 25 degrees Celsius. That's lower than chocolate's melting point, so it stays solid. But when you hold it in your hand, something interesting happens. Your skin is warmer than the air around you. Heat transfers from your hand into the chocolate. As the temperature rises past 30 degrees, the cocoa butter crystals begin to break apart. And that's when melting begins. Now here's something even more fascinating. Chocolate makers don't just melt and cool chocolate randomly. They use a process called tempering. Tempering carefully controls temperature changes so that the cocoa butter forms the most stable and desirable crystal structure. This gives chocolate its glossy shine, smooth texture, and satisfying snap when you break it. If chocolate isn't tempered properly, it can look dull or develop a white coating called bloom. That happens when fat crystals rise to the surface. So when you hear that clean snap when breaking a chocolate bar, you're actually hearing perfect crystal structure in action. But melting isn't just about temperature, it's also about sensation. When chocolate melts in your mouth, it spreads across your tongue. This activates taste receptors and releases aroma compounds at the same time.
Before we finish, there's something even more interesting. Not all chocolate tastes the same, and that's because not all cacao is the same. There are 3 main types of cacao used to make chocolate. The first is Criollo. Criollo is rare and considered the most premium cacao in the world. It has a delicate, complex flavor, often described as fruity or floral. Soil composition, climate, rainfall, and fermentation methods all influence the final taste. Cacao from Ecuador may taste floral and aromatic. Cacao from Madagascar often has fruity, slightly acidic notes. Cacao from Ghana typically delivers a bold, classic chocolate flavor. This is called terroir, the environmental factors that shape agricultural products.
Now let's look at the global scale of chocolate production. Every year, the world produces around 5 million metric tons of cacao beans. That's millions of tons of raw material, all grown in tropical regions near the equator. More than 70% of the world's cacao comes from West Africa. The largest producer in the world is Ivory Coast, contributing roughly 40% of global supply. Right behind it is Ghana, producing around 15 to 20%. Together, these two countries supply more than half of the world's chocolate industry. Other major producers include Indonesia, Ecuador, Nigeria, and Cameroon. Indonesia is the largest cacao producer in Asia. Ecuador is known for its high-quality fine-flavor cacao. But here's something many people don't realize. Most cacao is grown by smallholder farmers. There are over 5 to 6 million cacao farmers worldwide, and many farms are small, often less than 5 hectares. Chocolate is a global industry worth over $100 billion per year. Yet it all begins with cacao pods harvested by hand. After harvesting, the beans must be fermented, dried, shipped, roasted, ground, and processed before they become chocolate. So when you hold a simple chocolate bar, you're holding the result of tropical agriculture, global trade, food chemistry, and industrial science. Chocolate connects continents, from farms in West Africa to factories in Europe to stores around the world. It's not just candy. It's one of the most globally interconnected foods on Earth. And every time it melts in your mouth, you're re-experiencing the final step of a worldwide scientific journey. And now, think about this. A single chocolate bar begins its journey in the humid air of a tropical forest. Under the shade of tall trees near the equator, cacao pods grow quietly. Farmers harvest them by hand. They split them open. They ferment the beans. They dry them under the sun. From there, the beans travel across oceans. They are roasted in factories thousands of miles away, ground into cocoa mass, separated into cocoa solids and cocoa butter, carefully tempered to form perfect crystal structures. All of this so that one small piece of chocolate melts at exactly the right moment. Not too early, not too late, just as it touches your tongue. Inside that melting sensation is tropical climate, agricultural science, crystal chemistry, heat transfer, neuroscience, global trade. Chocolate is not simple. It is geography. It is physics. It is chemistry. It is human innovation. It connects farmers in West Africa, scientists in laboratories, manufacturers in Europe, and you. In one bite, you experience a journey across continents. So the next time chocolate melts in your mouth, pause. Because what feels ordinary is actually extraordinary. Food is never just food. It is science in motion. This is Tiny Food Scientists, where food meets science.